Chapter 3 Linear Regressions 1. Introduction. We have seen whether the correlation between two variables is positive or negative is known by the correlation coefficient. Moreover, we get numerical measure of the closeness of the variables. But the coefficient of correlation fails to provide the expected value of one variable for the given value of the other variable. When some relation exists between two variables, many times it is necessary to obtain the approximate or estimated value of one variable for a known value of the other variable using this relation. Example: we know that there is a correlation between advertisement cost and sale of an item. Now, for some given amount of advertisement cost, if we want to know the corresponding expected sale, then it is not possible to obtain it only by correlation. For this, it is necessary to use the concept of regression. The literal meaning of regression is to avert or return to the mean value. The term regression was first used by a statistician, Sir Francis Galton, during his study of human inheritance. He had collected the information about the height of 1,000 pairs of fathers and sons. He revealed the following interesting results. 1. Tall fathers have tall sons and short fathers have short sons. 2. The average height of sons of a group of tall fathers is less than average height of group of tall fathers. 3. The average height of sons of a group of short fathers is greater than average height of group of short fathers. So, it is clear from the above findings that the heights of sons show regressive tendency with respect to the height of their fathers. The existence of this tendency restricts the human to split into two races of pygmies and giants. So, Sir Francisco Galton has given the name regression to describe such relation. Regression is a functional relation between two correlated variables. We shall study the concept of regression under the assumption that there exists a cause-effect relationship between two variables. 2. Linear regression model. A set of one or more equations representing a relation or a problem is called a model. A statistical model which describes the cause and effect relationship between two variables is called a regression model. Generally, out of two variables having cause-effect relationship, the causal variable is denoted by x. We shall call this variable as independent or explanatory variable and effect variable is denoted by y. We shall call this variable as dependent or explained variable. 1. In case of advertisement cost and sales, generally because of increase or decrease in the advertisement cost, corresponding sales also increases or decreases. So, we shall take advertisement cost as independent variable x and sales as dependent variable y. 2. In case of rainfall and yield of rice in some region, it is very clear that yield of rice depends on rainfall. So, we shall take rainfall as independent variable x and yield of rice as dependent variable y. In a regression model, the dependent variable y is expressed in the form of an appropriate mathematical function of the independent variable x. Y is equal to alpha plus beta x plus u, where y is equal to dependent variable, x is equal to independent variable, alpha is equal to constant, beta is equal to constant, u is equal to disturbance variable of the model. The inadequacy of the linearity between two variables x and y is shown by u. The perfect linear relation is possible in natural science like mathematics. So, the disturbance variable u obviously becomes 0 in such a case. In other words, when there is a perfect linear correlation between two variables x and y, then the regression model is y is equal to alpha plus beta x plus u. But we know that exact linear relation between the variables is not always possible in business, economic, and social science, as these correlated variables are also affected by other factors. Thus, when there is a partial correlation between the variables x and y, then the linear regression model is y is equal to alpha plus beta x plus u. From the above discussion, we can define linear regression in simple words as follows. A mathematical or functional relationship between two correlated variables which helps in estimating the value of dependent variable for some given that is known value of independent variable is called linear regression. 3. Fitting of regression line. In a scatter diagram of two correlated variables, if the points are clustered around a line, we can say that there is a linear regression. The method of obtaining such a line expressing the relation between two variables is called fitting of a regression line. There are two methods for fitting a regression line. 1. Method of scatter diagram. 2. Method of least squares. Method of scatter diagram. Suppose an ordered pairs of observations of two correlated variables x and y are x1, y1, x2, y2 up to xn, yn. Using this data, we draw a scatter diagram. Now a line is drawn in such a way that it is close to almost all the points of the scatter diagram. If y is dependent variable and x is an independent variable, then such a line is called regression line of y on x, and an approximate value of dependent variable y can be obtained for any given value of independent variable x from it. Since no computation is required to draw such a line, it is very easy and quick method of fitting a regression line. But there is a problem in doing so. Different persons may draw different lines. As a result, different persons may provide different estimates of the dependent variable y for the same value of independent variable x. It can be seen very easily from the following scatter diagram. Two different persons have drawn two different lines L1 and L2 in the following scatter diagram of the same data. We can see that for some value a of independent variable x, corresponding estimated value is y1 from line L1 and it is y2 from the line L2. Thus, we get different estimates for dependent variable y from different lines for a single value of independent variable x. So, it can be said that this method is subjective. A line of regression drawn by this method is not the best fitted line because it does not guarantee the best estimate of the dependent variable. The method of least square is used to obtain such a best fitted regression line. Method of least squares. Suppose an ordered pairs of observations of two correlated variables x independent variable and y dependent variable are x1, y1, x2, y2 up to xn, yn. We shall draw a scatter diagram for this data to understand the method of least squares. If an equation of the best fitted line describing the linear regression between the variables x and y is y cap is equal to a plus bx, then the constants a and b of this line can be obtained by the method of least squares as follows. Let the estimated values of variable y corresponding to values x1, x2, x3 up to xn. Variable x are y cap 1, y cap 2, y cap 3 up to y cap n from the line, and the corresponding observed values y are y1, y2, y3 up to yn respectively. Now, for some x is equal to xi, estimated value of y from the line is y cap I is equal to a plus b xi. The vertical distance, that is distance parallel to y-axis between observed value yi and the estimated value y cap I is called an error in the estimation. It is denoted by EI. Therefore, EI is equal to yi minus y cap I is equal to yi minus a plus bxi is equal to yi minus a minus bxi, where I is equal to 1, 2, 3 up to n. Obviously, the error will be positive for points above the line. The error will be negative for points below the line, and it will be 0 for the points which are on the line. Now, the values of constants a and b of the fitted line y cap is equal to a plus bx, known as regression line of y on x, are obtained in such a way that the sum of the squares of the errors is minimum. That is, sigma ei square is equal to sigma yi minus y cap I whole square is equal to sigma yi minus a minus bxi whole square is minimum. By ignoring the suffix I for convenience, we can get such values of a and b by a simple algebraic method, which are as follows. B is equal to sigma x minus x bar into y minus y bar divided by sigma x minus x bar whole square is equal to n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x whole square, and a is equal to y bar minus bx bar. The line y cap is equal to a plus bx obtained by this method is a line passing as close as possible to the points of scatter diagram. The sum of squares of the errors is minimized while obtaining the line. Therefore, this method is called method of least squares. The value of b obtained by this method is called the regression coefficient of the regression line of y on x. B is also called slope of the regression line, and the constant a is called intercept of the regression line. Interpretation of regression coefficient b. B is equal to the estimated change in the value of y for a unit change in the value of x. That is, when b greater than 0, it means that the unit increase in the value of independent variable x implies an estimated increase of b units in the value of dependent variable y. That is, when b less than 0, it means that a unit increase in the value of independent variable x implies an estimated decrease of modulus b units in the value of dependent variable y. Note that the regression line obtained by the method of least squares is also known as the line of best fit. Note: Number 1. The regression coefficient b can also be denoted by byx. If not required, generally, we shall denote regression coefficient by b only. Number 2. If all the points in a scatter diagram are on one line, only then error will be 0 for all the points. Hence, the estimated value y cap is same as its observed value y. So, the form of the regression line will be y is equal to a plus bx in place of y cap is equal to a plus bx. Naturally, in this situation, r is 1 if b greater than 0 and r is minus 1 if b less than 0. Now, let us take some examples to obtain a regression line. Illustration 1. To study the relationship between the time of usage of cars and its average annual maintenance cost, the following information is obtained. Car, life of cars, years X, average annual maintenance cost 1000 rupees Y, 1, 3, 10, 2, 1, 5, 3, 2, 8, 4, 2, 7, 5, 5, 13, 6, 3, 8. Obtain the regression line of y on x. Find an estimate of average annual maintenance cost when the usage time of a car is 5 years. Also find its error. Life of a car is an independent variable, so we shall denote it by variable x, and maintenance cost is dependent variable, so we shall denote it by y. Considering at the data, we shall prepare the following table for obtaining the regression line. Car x, y, xy, x square, 1, 3, 10, 30, 9, 2, 1, 5, 5, 1, 3, 2, 8, 16, 4, 4, 2, 7, 14, 4, 5, 5, 13, 65, 25, 6, 3, 8, 24, 9. N is equal to 6. Sigma x is equal to 16. Sigma y is equal to 51. Sigma xy is equal to 154. Sigma x square is equal to 52. X bar is equal to sigma x divided by n is equal to 16 divided by 6 is equal to 2.67, and y bar is equal to sigma y divided by n is equal to 51 divided by 6 is equal to 8.5. Let us find the regression coefficient as follows. B is equal to n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x whole square. N is equal to 6. Sigma xy is equal to 154. Sigma x is equal to 16. Sigma y is equal to 15 and sigma x square is equal to 52. B is equal to 6 into 154 minus 16 into 51 divided by 6 into 52 minus 16 square is equal to 924 minus 816 divided by 312 minus 256 is equal to 108 divided by 56 is equal to 1.93. Now putting the values of x bar, y bar and b in the formula of A. A is equal to y bar minus bx bar. Y bar is equal to 8.5, x bar is equal to 2.67 and b is equal to 1.93. A is equal to 8.5 minus 1.93 into 2.67 is equal to 8.5 minus 5.15 is equal to 3.35. So the regression line of maintenance cost y on life of car x is y cap is equal to a plus bx. A is equal to 3.35 and b is equal to 1.93. Y cap is equal to 3.35 plus 1.93x. Putting x is equal to 5. Y cap is equal to 3.35 plus 1.93 into 5 is equal to 3.35 plus 9.65 is equal to 13. So, when the life of a car is 5 years, then its estimated maintenance cost is Rs 13,000. Illustration 2. The information for a year regarding the average rainfall in centimeter and total production of crop in terms of 5 districts is given below. Average rainfall in centimeter. Crop in turns 25, 84, 32, 90, 38, 95, 29, 88, 31, 93. Find the regression line of production of crop on rainfall and estimate the crop if average rainfall is 35 cm. X is equal to average rainfall in centimeter and Y is equal to crop in turns. X bar is equal to sigma x divided by n is equal to 155 divided by 5 is equal to 31 and Y bar is equal to sigma y divided by n is equal to 450 divided by 5 is equal to 90. X, y, x minus x bar is equal to 31, y minus y bar is equal to 90, x minus x bar into y minus y bar, x minus x bar whole square, 25, 84, minus 6, 36, 36, 32, 90, 1, 0, 0, 1, 38, 95, 7, 5, 35, 49, 29, 88, minus 2, 4, 4, 31, 93, 3, 3, 0, 0. Sigma x is equal to 155. Sigma y is equal to 450. Sigma x minus x bar is equal to 0. sigma y minus y bar is equal to 0. Sigma x minus x bar into y minus y bar is equal to 75. Sigma x minus x bar whole square is equal to 90. B is equal to sigma x minus x bar into y minus y bar divided by sigma x minus x bar whole square. Sigma x minus x bar into y minus y bar is equal to 75 and put sigma x minus x bar whole square is equal to 90 in the equation. B is equal to 75 divided by 90 is equal to 0.83. A is equal to y bar minus b x bar. Y bar is equal to 90, x bar is equal to 31 and b is equal to 0.83. A is equal to 90 minus 0.83 into 31 is equal to 90 minus 25.73 is equal to 64.27. So the regression line of crops Y on average rainfall X is Y cap is equal to A plus BX. A is equal to 64.27 and B is equal to 0.83. Y cap is equal to 64.27 plus 0.83x. Y cap is equal to 64.27 plus 0.83x. X is equal to 35. Y cap is equal to 64.27 plus 0.83 into 35 is equal to 64.27 plus 29.05 is equal to 93.32. So when average rainfall is 35 cm, then the production of crops are Y cap is equal to 93.32 ton. 4. Utility of the study of regression. The following are some utilities of regression. 1. We can determine a functional relation between two correlated variables. 2. Once the functional relation is established, it can be used to predict the unknown value of dependent variable y on the basis of known value of independent variable x. 3. We can determine the approximate change in the value of dependent variable y for a unit change in the value of independent variable x. 4. We can determine the error in the estimation of dependent variable obtained by a regression line. Regression is very useful for economists, planners, businessmen, administrators, researchers, etc. Shortcut method for computing regression coefficient. When the values of x and y are relatively large and or fractional, it is difficult to calculate the terms like x square, xy, etc. In such cases, an alternative formula can be used. It is based on the following property of regression coefficient. Property: the regression coefficient is independent of change of origin but not of change of scale. If b is equal to byx is a regression coefficient of a regression line of y on x, then using the above property, the following formula can be written for the regression coefficient by shortcut method. 1. If u is equal to x minus a and v is equal to y minus b, then b is equal to byx is equal to b vu is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square. 2. If u is equal to x minus a divided by cx and v is equal to y minus b divided by cy, then b is equal to byx is equal to b vu is equal to cy divided by cx is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square into cy divided by cx. Here a, b, cx and cy constants and cx greater than 0, cy greater than 0. Illustration 3. The following information is obtained from a study to know the effect of use of fertilization on the yield of cotton. Consumption of fertilizer 10 kg x. Yield of cotton per hectare quintals y. 28 128, 35 140, 25 115, 24 120, 20 105, 25 122, 20, 100. Obtain the regression line of y on x and estimate the yield of cotton per hectare if 300 kg fertilizer is used. X is equal to consumption of fertilizer 10 kg and y is equal to yield of cotton per hectare quintals. X bar is equal to sigma x divided by n is equal to 177 divided by 7 is equal to 25.29 and y bar is equal to sigma y divided by n is equal to 830 divided by 7 is equal to 118.57. For simplicity of calculation, we take u is equal to x minus 25 and v is equal to y minus 120. X, y, u is equal to x minus a is equal to 25. V is equal to y minus b is equal to 120. uv, u square, 28, 128, 3, 8, 24, 9, 35, 140, 10, 20, 200, 100, 25, 115, 0, minus 5, 0, 0, 24, 120, minus 1, 0, 0, 1, 20, 105, minus 5, minus 15, 75, 25, 25, 122, 0, 2, 0, 0, 20, 100, minus 5, minus 20, 100, 25. Sigma x is equal to 177. Sigma y is equal to 830. 13 minus 11. Sigma u is equal to 2. 30 minus 40. Sigma v is equal to minus 10. Sigma uv is equal to 399. Sigma u square is equal to 160. B is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square. N is equal to 7. Sigma uv is equal to 399. Sigma u is equal to 2. Now put the value of sigma v is equal to minus 10 and sigma u square is equal to 160 in the equation. B is equal to 7 into 399 minus 2 into in bracket minus 10 divided by 7 into 160 minus 2 square is equal to 2793 plus 20 divided by 1120 minus 4 is equal to 2813 divided by 1116 is equal to 2.52. A is equal to y bar minus bx bar. When y bar is equal to 118.57, x bar is equal to 25.29, b is equal to 2.52. A is equal to 118.57 minus 2.52 into 25.29 is equal to 118.57 minus 63.73 is equal to 54.84. The regression line of y on x is y cap is equal to a plus bx, where a is equal to 54.84 and b is equal to 2.52. Y cap is equal to 54.84 plus 2.52x when consumption of fertilizer x is equal to 300. Then yield of cotton per hectare y is y cap is equal to 54.84 plus 2.52x. X is equal to 300 divided by 10 is equal to 30. Y cap is equal to 54.84 plus 2.52 into 30 is equal to 54.84 plus 75.6 is equal to 130.44. So, when consumption of fertilizer X is equal to 300, then yield of cotton per hectare Y is 130.44 quintal. Illustration 4. From the following information of altitude and the amount of effective oxygen in air at the place, obtain the regression line of amount of effective oxygen Y on the altitude X, that is 305 meter is equal to 1000 feet. Altitude 305 meter X. Effective oxygen in percentage Y. 0, 20.9, 1, 20.1, 2, 19.4, 3, 17.9, 4, 17.9, 5, 17.3, 6, 16.6. If the altitude of a place is 7 units, 1 unit is equal to 305 meter. Estimate the percentage of effective oxygen in air at that place. Here, x is equal to altitude 305 meter and y is equal to effective oxygen in percentage. X bar is equal to sigma x divided by n is equal to 21 divided by 7 is equal to 3 and y bar is equal to sigma y divided by n is equal to 130.1 divided by 7 is equal to 18.59. Let us find the regression coefficient as follows. Since the values of x and y are fractional and all the values of y are divisible by 0.1, we shall use shortcut method. First we calculate regression line y cap is equal to a plus bx. So we shall take u is equal to x minus a divided by cx and v is equal to y minus b divided by cy as follows. A is equal to 3, cx is equal to 1, b is equal to 17.9 and cy is equal to 0.1. X, y, u is equal to x minus a divided by cx, a is equal to 3, cx is equal to 1. V is equal to y minus b divided by cy, b is equal to 17.9, cy is equal to 0.1. uv, u square, 0, 20.9, minus 3, 30, minus 99, 1, 20.1, minus 2, 22, minus 44, 4, 2, 19.4, minus 1, 15, minus 15, 1, 3, 17.9, 0, 0, 0, 0, 4, 17.9, 1, 0, 0, 1, 5, 17.3, 2, minus 6, minus 12, 4, 6, 16.6, 3, minus 13, minus 39, 9. Sigma x is equal to 21. Sigma y is equal to 130.1. 6 minus 6, sigma u is equal to 0. 67 minus 19, sigma v is equal to 48. Sigma uv is equal to minus 200. Sigma u square is equal to 28. B is equal to buv is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square into cy divided by cx. Here n is equal to 7. Sigma uv is equal to minus 200. Sigma u is equal to 0. Sigma v is equal to 48. Sigma u square is equal to 28. Cy is equal to 0.1 and cx is equal to 1. B is equal to 7 into minus 200 minus 0 into 48 divided by 7 into 28 minus 0 square into 0.1 divided by 1 is equal to minus 1400 minus 0 divided by 196 minus 0 into 0.1 divided by 1 is equal to minus 1400 into 0.1 divided by 196 is equal to minus 140 divided by 196 is equal to minus 0.71. A is equal to y bar minus bx bar. Y bar is equal to 18.59, x bar is equal to 3 and b is equal to minus 0.71. A is equal to 18.59 minus into minus 0.71 into 3 is equal to 18.59 plus 2 plus 1 3 is equal to 20.72. The regression line of y on x is y cap is equal to a plus bx, putting a is equal to 20.72, b is equal to minus 0.71, y cap is equal to 20.72 minus 0.71x. When altitude of a place is 7 units, 1 unit is equal to 305 meter. estimate the percentage of effective oxygen in air is y cap is equal to 20.72 minus 0.71x, where x is equal to 7. Y cap is equal to 20.72 minus 0.71 into 7 is equal to 20.72 minus 4.97 is equal to 15.75. So, when the altitude of a place is 7 units, that is 1 unit is equal to 305 meter. Estimate the percentage of effective oxygen in air is y cap is equal to 15.75%. Illustration 5. A sample of 7 students is taken from the students coming from abroad in the current year to study in University of the Gujarat state. The information regarding their IQ and the marks obtained in an examination of 75 marks is given below. Student IQ X, marks Y, 1 85 46, 2 95 50, 3 100 50, 4 90 45, 5 110 60, 6 125 70, 7 70 40. Obtain the regression line of Y on X and estimate the marks of a student whose IQ is 120. Also find the error in estimation when IQ is 100. Here n is equal to 7, x bar is equal to sigma x divided by n is equal to 675 divided by 7 is equal to 96.43. Y bar is equal to sigma y divided by n is equal to 361 divided by 7 is equal to 51.57. Since the values of x and y are large, means are fractional, and all the values of x are divisible by 5, we shall use shortcut method. By taking a is equal to 95, b is equal to 50, cx is equal to 5, cy is equal to 1, we define u and v as follows. U is equal to x minus a divided by cx is equal to x minus 95 divided by 5, and v is equal to y minus b divided by cy is equal to y minus 50 divided by 1 is equal to y minus 50. IQ x, marks y, u is equal to x minus 95 divided by 5, v is equal to y minus 50, uv, u square, 85, 46, minus 2, minus 4, 8, 4, 95, 50, 0, 0, 0, 0, 100, 50, 1, 0, 0, 1, 90, 45, minus 1, minus 5, 5, 1, 110, 60, 3, 10, 30, 9, 125, 70, 6, 20, 120, 36, 70, 40, minus 5, minus 10, 50, 25. Total 675, 361, 2, 11, 213, 76. B is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square into cy divided by cx is equal to 7 into 213 minus 2 into 11 divided by 7 into 76 minus 2 square into 1 divided by 5 is equal to 1491 minus 22 divided by 532 minus 4 into 1 divided by 5 is equal to 1469 divided by 528 into 1 divided by 5 is equal to 1469 divided by 2640 is equal to 0.5564. Therefore, B equals to 0.56. Now, A is equal to y bar minus B x bar is equal to 51.57 minus 0.56 into 96.43 is equal to 51.57 minus 54.0008 is equal to minus 2.4308. Therefore, A equals to minus 2.43. So the regression line of y on x is y cap is equal to a plus bx. Therefore, y cap is equal to minus 2.43 plus 0.56x. Putting x is equal to 120. Y cap is equal to 2.43 plus 0.56 into 120 is equal to minus 2.43 plus 67.2. Therefore, y cap is equal to 64.77 marks. So, when the IQ of a student is 120, then his marks are approximately 65. Now, to obtain the error when IQx is equal to 100, first we have to find the estimate of y, that is y cap. Y cap is equal to minus 2.43 plus 0.56x. Taking x is equal to 100. Y cap is equal to minus 2.43 plus 0.56 into 100 is equal to minus 2.43 plus 56. Therefore, y cap is equal to 53.57 marks. But the observed value of y for x is equal to 100 is 50. See the given data. Therefore, error E is equal to y minus y cap is equal to 50 minus 53.57. Therefore, E is equal to minus 3.57 marks. Illustration 6. The information regarding maximum temperature x and sale of ice cream y of 6 different days in summer for a city is given below. Maximum temperature is equal to x in Celsius. Sale of ice cream is equal to y in lakh rupees. X bar is equal to 40, y bar is equal to 1.2. Sigma xy is equal to 306, s x square is equal to 20. Obtain the regression line of sale ice cream on maximum temperature. Estimate the sale of ice cream if the maximum temperature on a day is 42 Celsius. Here n is equal to 6, x bar is equal to 40, y bar is equal to 1.2, sigma xy is equal to 306, sx square is equal to 20. For calculate regression line, y cap is equal to a plus bx. Find value of a and b. B is equal to sigma xy minus n x bar y bar divided by n into sx square is equal to 306 minus 6 into 40 into 1.2 divided by 6 into 20 is equal to 306 minus 288 divided by 120 is equal to 18 divided by 120 is equal to 0.15. A is equal to y bar minus bx bar is equal to 1.2 minus 0.15 into 40 is equal to 1.2 minus 6 is equal to minus 4.8. So the regression line of y on x is y cap is equal to a plus bx. Putting a is equal to minus 4.8, b is equal to 0.15, x is equal to 42. Y cap is equal to minus 4.8 plus 0.15x. Y cap is equal to minus 4.8 plus 0.15x. Y cap is equal to minus 4.8 plus 0.15 into 42 is equal to minus 4.8 plus 6.3 is equal to 1.5. So, on maximum temperature, x is equal to 42 degrees Celsius, estimate sale of ice cream is rupees 1.5 lakh. 5. Regression coefficient from covariance and correlation coefficient. When the summary measures like mean, standard deviation or variance, covariance, correlation coefficient are known for bivariate data of two variables x and y. Regression coefficient and the line of regression can be obtained as follows. 1. When the measures like x bar, y bar, sx square or sx, sy square or sy and covariance xy are known. B is equal to covariance xy divided by variance of x is equal to covariance xy divided by sx square and A is equal to y bar minus b x bar, where covariance xy is equal to sigma x minus x bar into y minus y bar divided by n is equal to sigma xy minus n x bar y bar divided by n. Sx square is equal to sigma x minus x bar whole square divided by n is equal to sigma x square divided by n minus sigma x divided by n whole square is equal to sigma x square divided by n minus x bar square. Sy square is equal to sigma y minus y bar whole square divided by n is equal to sigma y square divided by n minus sigma y divided by n whole square is equal to sigma y square divided by n minus y bar square. 2. When the measures like x bar, y bar are sx or sx square and sy or sy square are known. B is equal to r into standard deviation of y divided by standard deviation of x is equal to r into sy divided by sx and A is equal to y bar minus bx bar. The regression line of y on x, that is y cap is equal to a plus bx, can be obtained by putting values of a and b. Now we consider some examples in which some summary measures are known and the regression line is to be obtained. Illustration 7. The following measures are obtained to study the relation between rainfall in centimeter x and yield of bajri in quintal per hectare y in 10 different regions during monsoon. N is equal to 10, x bar is equal to 40, y bar is equal to 175, s is equal to 12, covariance xy is equal to 360. Obtain the regression line of yield y on rainfall x. Answer. Here covariance xy is equal to 360 and sx is equal to 12. Therefore, sx square is equal to 144. B is equal to covariance xy divided by sx square is equal to 360 divided by 144. Therefore, B is equal to 2.5 and A is equal to y bar minus bx bar is equal to 175 minus 2.5 into 40 is equal to 175 minus 100. Therefore, A is equal to 75. So the regression line of y on x is y cap is equal to a plus bx. Therefore, y cap is equal to 75 plus 2.5x yearly income x of a family and their yearly investment y in mutual funds. The following information is shown for a sample of 100 families of a city. X is equal to annual income of a family, lakh rupees. Y, annual investment in mutual fund of a family, 1000 rupees. X bar is equal to 5.5. Y bar is equal to 40.5. Sx is equal to 1.2. Sy is equal to 12.8. R is equal to 0.65. Obtain the regression line of annual investment in mutual fund of a family on their annual income. Estimate the annual investment in mutual fund of a family whose annual income is equal to 4.5 lakh. Answer. Here n is equal to 100, x bar is equal to 5.5, y bar is equal to 40.5, sx is equal to 1.2, sy is equal to 12.8 and r is equal to 0.65. Now b is equal to r into sy divided by sx is equal to 0.65 into 12.8 divided by 1.2 is equal to 6.9333. Therefore, b equals to 6.93 and a is equal to y bar minus bx bar is equal to 40.5 minus 6.93 into 5.5 is equal to 40.5 minus 38.115 is equal to 2.385. Therefore, a equals to 2.39. So the regression line of y on x is y cap is equal to a plus bx. Therefore, y cap is equal to 2.39 plus 6.93x. Putting x is equal to 4.5. Y cap is equal to 2.39 plus 6.93 into 4.5 is equal to 2.39 plus 31.185 is equal to 33.575. Therefore, y cap equals to 33.58. So, when annual income of a family is rupees 4.5 lakh, then estimated investment in mutual fund is rupees 33.58 thousand. Illustration 9. The following information is obtained to study the relationship between average rainfall in centimeter and the yield of maize in quintal per hectare in different taluka of Gujarat. Particulars: rainfall in centimeter x, yield of maize quintal per hectare y, mean 82 180, variance 64 225, correlation coefficient is equal to 0.82. Estimate the yield of maize when the rainfall is 60 cm. Here x bar is equal to 82, y bar is equal to 180, r is equal to 0.82, sx square is equal to 64. Therefore, sx is equal to 8 and sy square is equal to 225. Therefore, sy is equal to 15 are given. To estimate the yield of maize y when the rainfall x is 60 cm, we obtain the regression line of y on x. Y cap is equal to a plus bx. Now, b is equal to r into sy divided by sx. Putting r is equal to 0.82. Sy is equal to 15 and sx is equal to 8. We get b is equal to 0.82 into 15 divided by 8 is equal to 12.3 divided by 8 is equal to 1.54. A is equal to y bar minus bx bar. Putting y bar is equal to 180, b is equal to 1.54 and x bar is equal to 82. We get a is equal to 180 minus 1.54 into 82 is equal to 180 minus 126.28 is equal to 53.72. Putting a is equal to 53.72 and b is equal to 1.54 in y cap is equal to a plus bx. The regression line of yield of maize y on the rainfall x obtained is y cap is equal to 53.72 plus 1.54x. Estimate of yield of maize y when rainfall x is equal to 60 cm. Putting x is equal to 60 in y cap is equal to 53.72 plus 1.54x. We get y cap is equal to 53.72 plus 1.54 into 60 is equal to 53.72 plus 92.40 is equal to 146.12. Hence, the estimate of yield of maize obtained is y cap is equal to 146.12 quintal per hectare. Illustration 10. The following results are obtained to study the relation between the price of battery cell of wristwatch in rupees x and its supply in 100 units y. N is equal to 10, sigma x is equal to 130, sigma y is equal to 220, sigma x square is equal to 2288, sigma xy is equal to 3467. Obtain the regression line of y on x and estimate the supply when price is rupees 16. Here n is equal to 10, sigma x is equal to 130, sigma y is equal to 220, sigma x square is equal to 2288 and sigma xy is equal to 3467. X bar is equal to sigma x divided by n is equal to 130 divided by 10 is equal to 13 and y bar is equal to sigma y divided by n is equal to 220 divided by 10 is equal to 22. We obtain the regression line of y on x. Y cap is equal to a plus bx. B is equal to n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x whole square is equal to 10 into 3467 minus 130 into 220 divided by 10 into 2288 minus 130 square is equal to 34,670 minus 28,600 divided by 22,880 minus 16,900 is equal to 6,070 divided by 5,980 is equal to 1.02. A is equal to y bar minus bx bar is equal to 22 minus 1.02 into 13 is equal to 22 minus 13.26 is equal to 8.74. Regression line of y on x, putting a is equal to 8.74 and b is equal to 1.02 in y cap is equal to a plus bx, we get y cap is equal to 8.74 plus 1.02x. Estimate of supply y when price x is equal to rupees 16. Putting x is equal to 16 in y cap is equal to 8.74 plus 1.02x, we get y cap is equal to 8.74 plus 1.02 into 16 is equal to 8.74 plus 16.32 is equal to 25.06. Hence, the estimate of supply obtained is y cap is equal to 25.06 100 units. Illustration 11. The electricity is generated by windmill manufactured by a company. The following information is obtained by recording 5 observations regarding the velocity of wind, kilometer per hour, and generation of electricity in watts by a unit of the company. Velocity of wind is equal to x kilometer per hour. Electricity generation is equal to y watts. X bar is equal to 20. Y bar is equal to 186. Sigma xy is equal to 23,200. Sx square is equal to 50. Obtain the regression line of electricity generation y on velocity of wind x. Estimate the electricity generation if the velocity of wind is 25 km per hour. Here n is equal to 5. Sigma xy is equal to 23,200. X bar is equal to 20. Y bar is equal to 186 and Sx square is equal to 50. Now B is equal to covariance xy divided by Sx square is equal to sigma xy minus n x bar y bar divided by n into Sx square is equal to 23,200 minus 5 into 20 into 186 divided by 5 into 50 is equal to 23,200 minus 18,600 divided by 250 is equal to 4,600 divided by 250. Therefore, B is equal to 18.4. A is equal to y bar minus bx bar is equal to 186 minus 18.4 into 20 is equal to 186 minus 368. Therefore, A is equal to minus 182. So, the regression line of y on x is y cap is equal to a plus bx. Therefore, y cap is equal to minus 182 plus 18.4x. Putting x is equal to 25. Y cap is equal to minus 182 plus 18.4 into 25 is equal to minus 182 plus 460. Therefore, y cap is equal to 278. So, when the velocity of wind is 25 km per hour, approximately 278 once electricity is generated. 6. Coefficient of determination. We know that regression is a functional relation between two correlated variables, and it is useful to estimate the value of dependent variable for some given value of independent variable. The coefficient of determination is a measure to find the reliability of such an estimate. Suppose the regression line of y on x is y cap is equal to a plus bx, then the square of the correlation coefficient between observed values of dependent variable y obtained from the observations and its estimated values y cap which are obtained from the regression line is called the coefficient of determination. It is denoted by r square. Therefore, r square is equal to r y cap whole square. It can be easily checked that r square is same as r square xy or r square. R square is equal to r y cap whole square is equal to r ya plus bx whole square is equal to r xy whole square is equal to r xy whole square. Therefore, r square is equal to r square. Therefore, r is independent of change of origin and scale. So, from variable y cap is equal to a plus bx. Subtracting a and then dividing by 5, the value of r will not change. Since r square is equal to r square, we can say that the reliability of an estimate of dependent variable y largely depends on the correlation coefficient r between two variables x and y. If r is equal to plus or minus 1, then r square is equal to r square is equal to 1, and there is a perfect linear correlation between x and y. So, we can say that the estimates of y obtained from the regression line are 100% reliable. But if r is equal to 0, then r square is equal to r square is equal to 0, and there is no linear correlation between x and y. So, we can say that the estimates of y obtained from the regression line are not reliable. It is clear from the above discussion that high value of r square shows that a good linear correlation exists between two variables x and y. So, we can check whether the linearity assumption of regression is valid or not from the measure of coefficient of determination r square. If the value of r square is nearer to 1, the assumption of linearity of regression is valid, but if the value of r square is nearer to 0, the assumption of linearity of regression between x and y is not valid. How much variation in the independent variable y can be explained by the regression line can be obtained from the coefficient of determination. Example, if r is equal to 0.9 for some data, then coefficient of determination is equal to 0.9 whole square is equal to 0.81. And therefore, r square is equal to 100% is equal to 81%. So, it can be said that out of total variation in variable y, the explanation of 81% variation is obtained from the regression line. So, we can say that the regression model used for the given data is suitable. Illustration 12. The following table shows the experience of technicians in years employed at various companies and their monthly salary in 1000 rupees. Experience years x, monthly salary 1000 rupees y. 12, 22, 8, 15, 16, 25, 20, 30, 5, 12, 14, 24, 10, 20. Calculate the coefficient of determination and check the validity of the linearity assumption of regression between the years of experience and the monthly salary. Here, n is equal to 7, x bar is equal to sigma x divided by n is equal to 85 divided by 7 is equal to 12.14. Y bar is equal to sigma y divided by n is equal to 148 divided by 7 is equal to 21.14. Experience year x, monthly salary 1000 rupees y, xy, x square, y square. 12, 22, 264, 144, 484, 8, 15, 120, 64, 225, 16, 25, 400, 256, 625, 20, 30, 600, 400, 900, 5, 12, 60, 25, 144, 14, 24, 336, 196, 576, 10, 20, 200, 100, 400, total 85, 148, 1980, 1185, 3354. R square is equal to R square is equal to, in big bracket, n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square. Big bracket close whole square is equal to, in big bracket, 7 into 1980 minus 85 into 148 divided by under root 7 into 1185 minus 85 square into under root 7 into 3354 minus 148 square, big bracket close whole square, is equal to 13,860 minus 12,580 whole square divided by 8,295 minus 7,225 into 23,478 minus 21,904 is equal to 1,280 square divided by 1,070 into 1,574 is equal to 16,38,400 divided by 16,84,180 is equal to 0.9728. Therefore, R square equals to 0.97. The value of R square is very near to 1. So, we can say that the linearity assumption of regression between the years of experience and the monthly salary is valid. Note, for the above example, we can also compute R square by taking U is equal to X minus A and V is equal to Y minus B. Here, A and B are suitable constants. Illustration 13. The information of 8 construction companies regarding the number of contracts received in a year and the annual profit is as follows. Number of contracts. Annual profit lakh rupees. 2, 100, 5, 300, 9, 700, 12, 1000, 6, 350, 4, 250, 8, 700, 10, 750. Obtain the regression line of the annual profit on the number of contracts. Verify the reliability of the regression model. X is equal to number of contracts and Y is equal to annual profit lakh rupees. X bar is equal to sigma x divided by n is equal to 56 divided by 8 is equal to 7 and Y bar is equal to sigma y divided by n is equal to 4150 divided by 8 is equal to 518.75. For y cap is equal to a plus bx, we calculate a and b. Since the values of x and y are large, means are fractional, and all the values of y are divisible by 50. By taking a is equal to 8, b is equal to 700 and cy is equal to 50, we define u and v as follows. U is equal to x minus a and v is equal to y minus b divided by cy. X, y, u is equal to x minus a is equal to 8, v is equal to y minus b divided by cy, b is equal to 700, cy is equal to 50. uv, u square, v square. 2, 100, minus 6, minus 12, 72, 36, 144. 5, 300, minus 3, minus 8, 24, 9, 64. 9, 700, 1, 0, 0, 1, 0. 12, 1000, 4, 6, 24, 16, 36. 6, 350, minus 2, minus 7, 14, 4, 49. 4, 250, minus 4, minus 9, 36, 16, 81, 8, 700, 0, 0, 0, 0, 0, 10, 750, 2, 1, 2, 4, 1. Sigma x is equal to 56. Sigma y is equal to 4150. 7 minus 15, sigma u is equal to minus 8. 7 minus 36, sigma v is equal to minus 29. Sigma uv is equal to 172. Sigma u square is equal to 86. Sigma v square is equal to 375. B is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square into cy divided by cx. N is equal to 8. Sigma uv is equal to 172. Sigma u is equal to minus 8. Sigma v is equal to minus 29. Sigma u square is equal to 86. Cy is equal to 50 and cx is equal to 1. B is equal to 8 into 172 minus in bracket minus 8 into in bracket minus 29 divided by 8 into 86 minus in bracket minus 8 square into 50 divided by 1 is equal to 1376 minus 232 divided by 688 minus 64 into 50 divided by 1 is equal to 1144 into 50 divided by 624 is equal to 57,200 divided by 624 is equal to 91.67. A is equal to y bar minus bx bar. Y bar is equal to 518.75. X bar is equal to 7 and b is equal to 91.67. A is equal to 518.75 minus 91.67 into 7. A is equal to 518.75 minus 641.69 is equal to minus 122.94. So the regression line of y on x is y cap is equal to a plus bx, putting a is equal to minus 122.94 and b is equal to 91.67. Y cap is equal to minus 122.94 plus 91.67x. So the regression line of y on x is y cap is equal to minus 122.94 plus 91.67x. Now, reliability of a regression model can be examined by coefficient of determination r square. So we obtain it. R square is equal to r square is equal to in big bracket n sigma xy minus sigma x into sigma y divided by under root n sigma x square minus sigma x whole square into under root n sigma y square minus sigma y whole square big bracket close whole square. Putting sigma u square is equal to 86 and sigma v square is equal to 375. N is equal to 8. Sigma u is equal to minus 8. Sigma v is equal to minus 29. Sigma uv is equal to 172. R square is equal to in big bracket 8 into 172 minus in bracket minus 8 in bracket minus 29 big bracket close whole square divided by 8 minus into 86 minus in bracket minus 8 square into 8 into 375 minus in bracket minus 29 square is equal to 1376 minus 232 whole square divided by 688 minus 64 into 300 minus 8411 is equal to 1144 square divided by 624 into 2159 is equal to 13,08,736 divided by 13,47,216 is equal to 0.97. As the value of r square is very near to 1, it can be said that the regression model is reliable. 7. Properties of regression coefficient. 1. correlation coefficient R and regression coefficient B are either both positive and both negative, because we know that standard deviation Sx and Sy are always non-negative and -1 less than equal to R less than equal to 1. So, from B is equal to R into Sy divided by Sx, it can be understood that the sign of B will be same as that of R. 2. Regression coefficient is independent of change of origin but not independent of change of scale. This property is discussed in detail in the explanation of the shortcut method of calculation of regression coefficient. Note: the regression line of y on x always passes through the point x bar, y bar. Illustration 14. 6 pairs of father and son are selected in a sample of an experiment to know the relation between the heights of father in centimeter x and the heights of their adult sons in centimeter y. The following results are obtained from it. Sigma x is equal to 1020, sigma y is equal to 990, sigma x minus 170 whole square is equal to 60, sigma y minus 165 whole square is equal to 105, sigma x minus 170 into y minus 165 is equal to 45. Obtain the regression line of the heights of sons y on the heights of fathers x. Also verify the reliability of the regression model. X bar is equal to sigma x divided by n is equal to 1020 divided by 6 is equal to 170. Y bar is equal to sigma y divided by n is equal to 990 divided by 6 is equal to 165. Therefore, sigma x minus 170 whole square is equal to sigma x minus y bar whole square is equal to 60. Sigma y minus 165 whole square is equal to sigma y minus y bar whole square is equal to 105. Sigma x minus 170 into y minus 165 is equal to sigma x minus x bar into y minus y bar is equal to 45. Therefore, B is equal to sigma x minus x bar into y minus y bar divided by sigma x minus x bar whole square is equal to 45 divided by 60. Therefore, B is equal to 0.75. A is equal to y bar minus bx bar is equal to 165 minus 0.75 into 170 is equal to 165 minus 127.5. Therefore, A is equal to 37.5. So, the regression line of y on x is y cap is equal to a plus bx. Therefore, y cap is equal to 37.5 plus 0.75x. Now, to verify reliability of the regression model, let us obtain the coefficient of determination r square. R square is equal to, in big bracket, sigma x minus x bar into y minus y bar divided by sigma x minus x bar whole square into under root sigma y minus y bar whole square, big bracket close, whole square is equal to 45 square divided by 60 into 105 is equal to 2025 divided by 6300 is equal to 0.3214. Therefore, r square equals to 0.32. Since the value of r square is nearer to 0, it cannot be said that the regression model is reliable. Illustration 15. 1. If the regression line of y on x is y cap is equal to 12 minus 1.5x and the mean of x is 6, find the mean of y. 2. If the regression line of y on x is y cap is equal to 11.5 plus 0.65x and y bar is equal to 18, find x bar. 1. We know that the regression line always passes through a point x bar, y bar. So the y cap obtained by putting x bar in place of x in the regression line is y bar, or the x obtained by putting y bar in place of y cap is x. Putting x bar is equal to 6 in place of x in y cap is equal to 12 minus 1.5x. y cap is equal to 12 minus 1.5 into 6. Y cap is equal to 12 minus 9. Y cap is equal to 3. So, y bar is equal to 3. Therefore, the mean of y is 3. Number 2. As per the above discussion, the value of x obtained by putting y bar is equal to 18 in place of y cap in y cap is equal to 11.5 plus 0.65x, we get x bar. By putting y cap is equal to y bar is equal to 18 in y cap is equal to 11.5 plus 0.65x. 18 is equal to 11.5 plus 0.65x. 65 is equal to 0.65x. Therefore, x is equal to 65 divided by 0.65. Therefore, x is equal to 10. So, x bar is equal to 10. Therefore, the mean of x is 10. Illustration 16. 1. If x bar is equal to 5, y bar is equal to 11 and b is equal to 1.2, obtain the regression line of y on x. 2. If x bar is equal to 60, y bar is equal to 75 and sx square is to covariance xy is equal to 5:3. Obtain the regression line of y on x and estimate y for x is equal to 65 from it. Answer 1. Here b is equal to 1.2, x bar is equal to 5 and y bar is equal to 11. Now a is equal to y bar minus bx bar. Therefore, a is equal to 11 minus 1.2 into 5 is equal to 11 minus 6. Therefore, a is equal to 5. We get the regression line of y on x as follows. Y cap is equal to a plus bx. Therefore, y cap is equal to 5 plus 1.2x. Number 2. Here x bar is equal to 60, y bar is equal to 75 and sx square is to covariance xy is equal to 5:3. Sx square is to covariance xy is equal to 5:3. Therefore, sx square divided by covariance xy is equal to 5 divided by 3. Hence, covariance xy divided by sx square is equal to 3 divided by 5. Now, b is equal to covariance xy divided by sx square is equal to 3 divided by 5 is equal to 0.6 and a is equal to y bar minus bx bar is equal to 75 minus 0.6 into 60 is equal to 75 minus 36. Therefore, a is equal to 39. We get the regression line of y on x as follows. Y cap is equal to a plus bx. Therefore, y cap is equal to 39 plus 0.6x. Putting x is equal to 65. Y cap is equal to 39 plus 0.6 into 65 is equal to 39 plus 39. Therefore, y cap is equal to 78. So, for x is equal to 65, the estimated value of y is 78. Illustration 17. 1. The fitted regression line of y on x is y cap is equal to 50 plus 3.5x. If an observation 16,108 is used in fitting of the line, find the error in estimating y for x is equal to 16. 2. If one observation 10,30 is used in the fitting of the line y cap is equal to 22 plus 0.8x, find the error in estimating y for x is equal to 10. What can you deduce from the value of the error? 1. Putting x is equal to 16 in y cap is equal to 50 plus 3.5x. Y cap is equal to 50 plus 3.5 into 16 is equal to 50 plus 56. Therefore, y cap is equal to 106. And for x is equal to 16, corresponding y is equal to 108 is observed. Error e is equal to y minus y cap is equal to 108 minus 106. Therefore, e is equal to 2. So, the error in estimating y for x is equal to 16 is 2. 2. Putting x is equal to 10 in y cap is equal to 22 plus 0.8x. Y cap is equal to 22 plus 0.8 into 10 is equal to 22 plus 8. Therefore, y cap is equal to 30. And for x is equal to 10, corresponding y is equal to 30 is observed. error E is equal to y minus y cap is equal to 30 minus 30. Therefore, E is equal to 0. So, the error in estimating y for x is equal to 10 is 0. Since value of the error is 0, we can say that the point 10, 30 lies on the fitted line y cap is equal to 22 plus 0.8x. Note, for a regression line obtained by the method of least squares, the error is positive for the points above the line, negative for the points below the line, and it is 0 for the points which are on the line. Illustration 18. 1. If the regression line of y on x is y cap is equal to 25 plus 3x and covariance xy is equal to 48, find the standard deviation of x. Also find coefficient of determination if the standard deviation of y is 15. 2. For the regression line given in the above question, how many units should be increased in the value of x to increase approximately 50 units in y? Answer. 1. By comparing the regression line of y on x, y cap is equal to 25 plus 3x with its general form y cap is equal to a plus bx, we get regression coefficient b is equal to 3. Since covariance xy is equal to 48 is given, b is equal to covariance xy divided by sx square. Therefore, 3 is equal to 48 divided by sx square. Therefore, sx square is equal to 16. Therefore, sx is equal to 4. So, the standard deviation of x is 4. Now, the standard deviation of y, sy is equal to 15 is given. So, coefficient of determination r square is equal to covariance xy divided by sx into sy whole square. Therefore, r square is equal to 48 divided by 4 into 15 whole square is equal to 0.8 square is equal to 0.64. Second method, b is equal to r into sy divided by sx. Therefore, 3 is equal to r into 15 divided by 4. Therefore, r is equal to 3 into 4 divided by 15. Therefore, r is equal to 0.8. Therefore, r square is equal to r square is equal to 0.8 square is equal to 0.64. 2. Y cap is equal to 25 plus 3x and regression coefficient b is equal to 3. It indicates that if the value of x is increased by 1 unit, then estimated value of y is increased by 3 units. So, if the value of y is to be increased approximately by 15 units, then the value of x should be increased by 15 divided by 3 is equal to 5 units. Illustration 19. 1. If the regression line is y cap is equal to x divided by 2 plus 5 and sy is to sx is equal to 5 is to 8, find the coefficient of determination. 2. If the regression line of y on x is 4x plus 5y minus 65 is equal to 0, find the value of regression coefficient b. 1. By comparing the regression line y cap is equal to x divided by 2 plus 5 is equal to 1 divided by 2 into x plus 5 with its general form y cap is equal to a plus bx. We get b is equal to 1 divided by 2. Now, sy is to sx is equal to 5 is to 8. Sy divided by sx is equal to 5 divided by 8. And b is equal to r into sy divided by sx. Therefore, 1 divided by 2 is equal to r into 5 divided by 8. Therefore, r is equal to 1 divided by 2 into 5 divided by 8. Therefore, r is equal to 0.8. The coefficient of determination r square is equal to r square is equal to 0.8 square is equal to 0.64. 2. The regression line of y on x 4x plus sy minus 65 is equal to 0 is given. Now we convert it into its general form. 4x plus 5y minus 65 is equal to 0. Therefore, sy is equal to 65 minus 4x. Therefore, y is equal to 65 minus 4x divided by 5. Therefore, y is equal to 65 divided by 5 minus 4x divided by 5. Therefore, y is equal to 13 minus 0.8x. By comparing it with y cap is equal to a plus bx, we get b is equal to minus 0.8. 8. Precautions while using regression. We know that regression is a functional relation between two correlated variables, and hence we can estimate the value of dependent variable from it. The regression analysis is very useful in decision making in the practical fields like economics, trade, industry, education, psychology, sociology, medicine, planning, etc. In spite of vast application of regression analysis, some precautions are necessary while using it. Number 1. The reliability of the estimate can be verified by the coefficient of determination R². So, we should use the estimate only after ascertaining the linearity of regression by the coefficient of determination. 2. Another point which is necessary to keep in mind while using the regression analysis is the regression relation obtained by the scatter diagram or by the method of least squares should not be used for the values which are very far from the given values of the independent variable. Example, if for some data there is a high degree of correlation between the rainfall and the yield of wheat, we can say that as rainfall increases, yield of wheat also increases. Now, using the regression relation obtained from the given data, if for some value of rainfall, corresponding yield of wheat is to be estimated, then the estimate of yield of wheat can be proper only when the value of rainfall is around the given values of rainfall. If there is heavy rain, then the crop may get damaged and the yield of wheat may also decrease. In such a case, the dependent variable, that is yield, estimated from the above mentioned regression relation may be wrong. List of formula. Equation of regression line. Y cap is equal to a plus bx, where b is equal to byx is equal to regression coefficient. 1. B is equal to sigma x minus x bar into y minus y bar divided by sigma x minus x bar whole square. 2. B is equal to n sigma xy minus sigma x into sigma y divided by n sigma x square minus sigma x whole square. 3. B is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square. Here, u is equal to x minus a and v is equal to y minus b. 4. B is equal to n sigma uv minus sigma u into sigma v divided by n sigma u square minus sigma u whole square into cy divided by cx. Here, u is equal to x minus a divided by cx and v is equal to y minus b divided by cy. 5. B is equal to r into sy divided by sx. 6. B is equal to covariance xy divided by sx square. 7. A is equal to y bar minus bx bar. 8. Coefficient of determination r square is equal to r y cap whole square is equal to r xy whole square is equal to r